I have now started recording. Welcome, everybody. This is the SAT math training module. First, I want to start by showing you, so just a quick overview of the syllabus that was shared with you today, just to get an idea of how we will be progressing with this course slash session slash. So you should be able to see my screen now. Yeah. And maybe I'll share the screen for those who are online. So here's what's happening. We have this set of skills, which are set by the College Board question bank, and we would like to cover them over the course of 16 sessions. We have 19 skills in total, which is almost one skill per session. That's not difficult to comprehend. This is just some organizational stuff. So every day we'll have these sessions. Not every day. Mondays and Wednesdays every week. Same time, 20:45 until 10. We'll be posting topic worksheets, which will be a supplement of what we'll be working on. So basically, the approach is about focusing on topics. But then, if you want to if you want to test yourself with how you would perform when given different topics, you can of course do this by means of practice tests. And there is a certain specific feature about this. About a set of material, which is that it is not available in any standard practice test. So you can do as many previous tests as you can, and you don't have to worry about them overlapping with your preparation. So we're doing whatever you're doing, it doesn't have to intersect with what we are doing. So that's good. So because you don't want to be doing the same problem twice. These are my contact info. If you have bad math jokes, that would be highly appreciated. And this is one of my favorite quotes. It's also by a mathematician. I really think it's very important that we expose ourselves to this fear from not knowing things and making mistakes. People are usually very afraid of making mistakes, that they never learn anything, so they just stay in their place, and that's not so constructive. But if you take that frustration, if you take that fear and you turn it into something, and then you will be richly rewarded, not just in your pursuit of mathematics, but in all what life has to offer. Yeah, so these are the four main topics: algebra, advanced math, problem solving, and geometry. I've set out the exact number of questions we'll be doing for each topic, which is basically questions from the question bank. So these are all questions from the question bank. These are the topics, of course. Today we're going to talk about one variable linear equations. As a rule, we'll try to cover 33% of the material here, and the rest you will try to do on your own. And this is a schedule. So I leave this here and I make a small remark. So let's say you are really good with ratios, rates, proportions, and units. then you don't need to show up on not the 11th, but the 13th of November. So as a matter of fact, you might not even need to cover all of these skills. So you should definitely not show up to every single class if you already know most of the stuff. So you can feel free to skip some stuff, and you can focus instead on doing the worksheets, which I'll provide using the questions on the question bank. Yeah, and I wanted to know if you have any questions. The worksheets are in Moodle. I will still work on them and post them, but they should be posted in Moodle. Yeah, I'll try to do that. But if I cannot manage, I'll probably post them as PDF. That would mean that I was a bit too lazy to post them on Moodle, and you know, stuff happens. So I still need to figure that out. But anyway, so I think we're good. More questions? Okay, sounds good. Don't know if there are questions online. That would be good as well. Let me go back here. I'll stop sharing my screen and I'll start sharing my other screen. It's also a screen, but it's my tablet screen. So, okay. That's not the time for technical difficulties. Please work. Thank you, I guess. Yeah, it doesn't sound good, but here we are. Now, yes, it's here, and now I can share my screen, which will be available here. Give me 10 seconds. Yes, I think we can get going now. You can see my screen, everything's good, everything is nice. So as I said, the first topic will be linear equations in one variable. The question bank does a very nice thing of sorting the questions by difficulty, easy, medium, and hard. And so this is what we will be working on. We'll be working equally on different difficulties of questions. And as we go through the questions, we'll explain the concepts. I really think that's the best way to learn, and that is using examples. So here I have a linear equation in one variable. Are you guys ready? Okay. 1, 2, 3. Okay. I'm just checking that the mic works. That's not too horrible. Okay. Now we go back. Yeah, so we have an equation, we have some choices. The choices are not really relevant in this case. It just says that 4x divided by 5 is equal to 20. And so to do this, we need to introduce some things. But before I introduce them, I will use them. That unintentionally rhymed. As many other things. So what I'm going to do here is it's 4x divided by 5, which is I can write it as 4/5 times x. I hope that's okay. Just 4/5. And if 4/5 of x is equal to 20, then I will multiply by something that I will call the multiplicative inverse. So I'll multiply both sides by 5/4. And then I get something that looks like this. You guys can see the screen, right? It's working. Everything's nice. That's amazing. 4/5 times x times 5/4. This is equal to 20 times 5/4. Now, multiplication is commutative, which means I can move this to the left and we put my x back to the right. And then I have, well, these two elements are inverses of each other. So they will give us an identity, which is going to be equal to 1. So we get that x is equal to 20 times 5/4. If you want to do 5/4 in your mind, I think that's going to be 25. But what's really going on here? I'm just saying nonsense that probably only I understand. Like if hypothetically this were the very first time you were hearing this, then it wouldn't really make much sense. So let me try to make sense of it. And so in our setup with equations in general, we start with numbers. I hope everybody knows what a number is. Yeah. So we start with numbers. Let's say 1, 2, 3, and so on and so on. Well, actually, just goes on. And we want to define something. We want to define some operations. So we want to be able to manipulate these numbers in some different ways. So at least on a very intuitive level, we can define something called addition. And you don't need to define what addition is. I mean, I think 1 + 2 is 3. Use your fingers. It's not recommended, but it's some sort of an axiom you use, so you know what addition is, and you know what an equation is. So an equation is just a statement which tells you that these two expressions are equivalent. So this is a mathematical fact that you could say. And there are some properties about addition which are commutativity. So 1 + 2 is equal to 2 + 1. I can switch them around. It's very nice. But then, and there's also this identity element, which is called 0. Have you heard of 0 before? Yes. Okay, that's amazing. So 0 is the number such that if you choose any number, really, any other number, let's say you choose any number a, you have a plus 0 is equal to 0. And that's very nice. So it is the identity for addition. So when you apply this operation with addition and any other element, you just get the right 0. Okay, that's not correct. It's a. Why didn't any of you correct me? You guys don't know. Okay, maybe it will be true if a was equal to 0, but anyway, I don't want to talk about it. So just pretend that this didn't happen. So that's something. That's what an identity is. And I hope you don't mind if I define one more thing, which is going to be an inverse. So I'll define an inverse for addition. So I'll write inverse. And for any number a, I'll define an additive. Hi, how's it going? I'll define an additive inverse, which I will call minus a. And this minus a has this property such that if I add a with minus a, I get the identity element. So I'm just setting out some rules. I know this is obvious for most of you, actually for all of you almost, I hope. But right now I'm just trying to change your perspective. So we're not really doing subtraction, we're adding the additive inverse. And if you think about it like this, then if you have an equation that looks like x plus 3, then you need to get rid of 3, then you add the additive inverse. So you get the identity. And so when you compose this x with the identity, you get x back again. That's basically how you solve the equation. So this is just a change of perspective. That's what we're trying to do here. And I will define the same thing for another operation, which I'll call multiplication. And so for multiplication, yeah, I need to multiply two numbers. So for example, let's say I want to find 3 times 2, I can define it as 3 plus 3, but 2 times. I don't need to go too deep into what multiplication is really, but I'm just saying this is multiplication. We know what it is. So I won't write what it is, but what I will say about it is that we have a multiplicative, so related to multiplication, identity. And does anyone know what this identity is? The multiplicative identity. Well, if you've not heard of it before, you might need another page, which is fine. So in this case, it is 1. So, just writing some stuff and go back now. And so the multiplicative identity, if you choose any number a, we have that a times 1 will give us a. So it's the same idea. You have an operation, and there's the element, which is the do nothing element. It's 1. And that is what it is. So if you choose any number and just multiply it by 1, you get the same number back again. So that's how we define it. And then we can talk about the inverse, just like we did with addition. So I'll do x, then inverse. And that just says that for any number a, we define 1 over a. To be the number for which when you multiply this number by a, you get 1. So these are just, this is what is called the multiplicative inverse of a. Now, there's a caveat here. 0 is the only number which does not have an inverse. They need to write not equal to 0. Otherwise, they'll get in big trouble. And so this is just, again, this will be a change of perspective. Instead of thinking of division, we want to think of multiplying by the multiplication inverse. And also it's good because if you have less operations, if it's just addition and multiplication, then it's much easier. So if you're dividing by a number, you're just multiplying by the multiplicative inverse of the same number. And then in that way, you get rid of subtraction, you get rid of fractions, and it's very nice. So this is just some stuff. And finally, the final thing I want to mention here is something called the distributive property. And this distributive property, it has a very nice property. The property has a property, and that is it links addition and multiplication. So links multiplication and addition. So that's good. What does it tell us? It tells us that if you have, for example, A times B plus C, then this will be equal to A times B plus A times C. By the way, I sometimes use the dot instead of the multiplication for multiplication. I hope that's okay. So that is how it is defined, how we can link addition and multiplication. So if you want to multiply a sum of numbers, you can multiply the first number, multiply the second number, and then add them together. So yeah, as I said, this is clear, of course, but it is very important to get back to the fundamentals. And I claim, it's a very strong claim, that you can solve any equation using these, I don't want to say axioms, but these things. Okay, I don't have the right word for it. So things. Yeah. So if we go back here to this very obscure thing, which I did not explain a single thing about, it makes perfect sense. Well, at least to me, because I still have not explained it. So I still need to explain it so that it makes sense. So I hope it is clear to you that so multiplication is commutative, which means I can move the terms around. So what happened here is that 4x divided by 5 can be written as 4 times x times 1 over 5. It can also be written as 4 over 5 times x. Now, usually when solving equations, the goal is to find x. But nobody tells you why. So that's not a good thing. You need to have purpose in life. That's not important. So
Just
yes.
instead of doing this, I might like confusing. I can just multiply 5 at both sides and then divide by 4 later. Or do I have to do this?
You don't have to do it. It's just a change of perspective. So here, I'm just showing work, maybe excessively. So I'm just showing every single step I'm doing here. So so this is equal to 4 over 5x. And if this is equal to 4 over 5x, and that is equal to 20, then I have a coefficient next to x. But here's the catch. If I multiply both sides by 5 over 4, then I have 4 over 5 times 5 over 4, which is what? It's the multiplicative inverse of 4 over 5. Why is this true? Okay. And why is it true? because 4 has a multiplicative inverse of 1/4. 4 is the number, 1/4 is the inverse. 5 has 5 is a number, 1/5 is the multiplicative inverse. So in that case, 4/5 has an inverse of 5/4. And if that is true, then it gives us a 1 times x here. And 1 is the multiplicative identity. So we get 1 times x is equal to x. So in just one step, I have that x is equal to 20 times 5/4, and then you can use your calculator for that. So again, it's just a change of perspective. And now it's a good time to look at more examples of questions. So here we forgot to choose the correct answer. That's amazing. It's 25. I mean, it's obvious, but so 4x plus 6 is equal to 12. Can somebody help me do this quickly using the facts that I've introduced so far? Yes.
It's 12.
So you would like to divide by, you would like to factor out the 2?
Yeah.
Sure. So factoring is basically you're using the distributive property, but in reverse. Right? Because if you do this, then you get 4x plus 6. Okay, that's good. That's still equal to 12. And then what do you want to do next?
What are we finding?
We're finding x.
Okay.
Right? Yes.
Then you can divide by 2 on both sides.
Yes, okay. So you want to multiply by the multiplicative inverse of 2. You do this. And then you get that 2x plus 3 is equal to 6. Oh, okay. So maybe, yeah, so maybe this is better. We should not try to find x. Maybe if we just give a quick glance at the choices, it will be much easier to save us more time. If I just find x and then I try to find which one is equivalent, that will take me a bit more time. So thank you. What is your name again?
Flavia.
Flavia, nice to meet you. I'm Omar. Yeah, so these questions are not particularly difficult. Here you have a word problem, which you would like to translate into something. What do you think the answer should be? A, but can you tell me why?
So for like if we're given C pounds, so for each pound costs $2.
Okay.
So then the dollars would be C.
Okay, so if C is 1, then it's just $2. If C is 2, 2 plus 2. And if C is 3, then it's 2 plus 2 plus 2, and so on. But this can be written as this. I mean, in the way that we've defined multiplication, which we didn't really define, we have indeed that this is 2 times C. So that is, it's not too difficult. It's nice. We're warming up now. You're of course, yeah. So I also wanted to say this. You're more than encouraged to interrupt me at any time with questions. So that is something I highly encourage. Okay. Then we have this problem. Principal, 25 flags, blue or yellow. Principal used 20 blue flags. How many yellow flags were used? 5, right? Because it's 25 flags in total, and it's equal to blue plus, please pretend that this is yellow. So the blue is 20, 25, and we want to find the yellow, which is not really yellow. So I mean, you do this in your mind. It's not complicated. We add the additive inverse of 20, so we get that the yellow part is equal to 25 minus 20, which is 5. This is good. Maybe we'll do a couple more, and then we will move on to some other questions. So we have this. What do you think the answer should be? So can you tell us what you did here?
Just divide both sides by 8.
Yeah, exactly. Just multiply by multiplicative inverse. The multiplicative inverse of 8 is 1/8. So we get 1 times x, which is 1. And 88 divided by 8 is 11. Yeah. This will get a bit harder, I think. Now. So here we're discussing solutions of the equation. That's something. Twice of a number plus 4 is equal to 10. How many numbers can satisfy this property? You said B. Yeah, but why doesn't it have 3 numbers?
Always you get one answer.
Yeah, but how, did you calculate it? Can you show me? Calculate it.
Subtract 4 from 10.
Okay, add the additive inverse of 4. So you get 2x.
Divide by 2.
Okay, and then you multiply by the multiplicative inverse. So you get x is equal to 10 minus 4 over 6. Sorry, over 2. So that is one number. It's not 2 numbers. It's not 3 numbers. I know this is obvious, and I know that you can count. But sometimes we get we might get that x is equal to, let's say, 2 things or 3 things, or maybe a whole class of things. So sometimes the solution is lives, let's say, in the 2-dimensional plane. It lives along, let's say, some line. So your solution would actually be an infinite line of numbers which lie on this line. So that is just some idea. It seems obvious, but I had a really good professor who always said it's not obvious unless you can prove it. So I think that's why I think it's important. And that is a word problem. Kathy has n CDs. Jerry has 3 more than twice the number of CDs. Can you help me write an equation out of this? So, yes, of course.
D.
Okay, that's quick. So you're saying it's D, but can you help me write the equation out of this?
Kathy has NCD.
Kathy has NCDs.
Jerry has 3 more than twice the number of CDs Kathy has. So
Okay.
3 more than twice the
So
number.
3 more
3 more than 2 times n.
than 2 times. So this is 2 times
2 times n.
the number of CDs that Kathy has, which is n, right? Number of CDs that Kathy has is it's 10. That is not 10, it's n. So that is the equation. And addition is commutative. So 3 plus 2n is equal to 2n plus 3. Or exercises. Let me see. Maybe we will skip some. I'll try to find something which has a good value. But that looks like an interesting problem. So a very interesting feature of the SAT is that it has choices. So if it goes really bad, you can just plug in the choices and see which one gives you 1. But then I would really like us to solve it here. So can you help me do that? The first obstacle I see is that we have 2 x is, I don't know what's the plural of x, but this is something for the SAT math instructor. Yeah, so we have 2x. Usually we want to have 1x. Can you help me do that?
Hello, can you hear me?
We definitely can hear you. Okay, please wait. Can you speak now?
Yeah.
That's much better. I don't know if you heard this as well.
Was that loud?
That was yeah, sure. Hi. Would you like
Hi.
to participate?
Yeah, sure.
Yeah. So how
So-
many?
So like you can take a x like out from the equation, you know, since both the numbers have x. So then it would be like x into 1/2 minus 1/6.
Okay, so you're comparing it. So you're trying to use the what's it called? You're trying to use the distributive property, and you see that this x is common. Here x is just like a. And so, but it's in this expanded form. So you want to group it. Okay.
Yeah.
Then
Then
what?
after that, you can you know, subtract 1/2
Yeah,
minus 1/6.
I can do this. Yeah, because that's what the distributive property is telling me. Okay.
Then you get like 1/3x.
Yeah, it will be 1/3x. You can use the calculator if you want to find this. You can also do it very quickly. So just
Like you can multiply both sides by 3, then it gives you x is equals to 3.
but you don't need to show that much work in the exam. So it's just x is equal to. You said one third, right? X times 1/3 is equal to 1.
Yeah.
So what is x going to be?
3, C. The answer is C.
Yes, but why? What did you do here?
You multiply both sides by 3.
Yeah, you multiply both sides by 3 because the multiplicative inverse of 1/3 is 3. They are both dual to each other. So when I multiply both sides by 3, I get here I get 1, and here I get 1 times 3, which is 3. So that is the answer to the question. Let me see. What is your name?
Yes, yes.
Iosias. It's good that you're here. I'm happy. Can you see the screen clearly? Can you see everything? Everything's good?
Yeah.
Okay.
Everything's perfect.
Yeah, amazing. Okay. Let's do a couple more and then move on to more challenging questions. Yeah, how about this? How about this one? So we have an equation here, equal to A, and we have another equation. So this is about really noticing some things. You just need to spot it. And if you want to do it quickly, of course, on the SAT, every second matters. Classically, you can, of course, just solve it. So 8 minus 2 is 6. 6 divided by 3 is 2. And then you plug in 2 times 9 is 18. And then 18 plus 6 is 24. And so the answer is 24. But there is a quicker way to do it. You guys know what this is.
Try to do the, I don't know how it's called, to factor out the 3x plus 2 in the second.
Mm-hmm.
Yeah.
Well, here's something. So this is like the bigger one per se, and this is not accurate, but here you can factor, or you can notice that 3x becomes 9x, and 2 becomes 6.
Right, right.
Yeah, exactly. So this is all being multiplied. So we take this whole equation and we multiply by 3. And so when we do this, we get 9x plus 6 is equal to 8 times 3, which is 24. So that is how it's like. As I said, of course, in the SAT, you need every second. Very important. So if you can notice these nuances, then it's very good. Let me find a nice problem now. So I like this problem. Maybe we can do it. Yeah. So some guy at the IRC has 43 books and wants to distribute them. They'll give each child 2 books, and then we have 7 books left over. So it's very important to understand how you can interpret the question itself and the data. From my side, personally, I like to use symbols to write down the facts. So I like to write down every single fact I have about the problem, and then see how I can utilize all of these. The SAT is a bit tricky because sometimes they give you extra data, which is not useful. But it is important to to write down what you have, see what you want to find, and try to build up your way from there. B is equal to 43. Each child will have 2 books. So let's say we have 2 books for the first child, and then 2 books for the second child, and then 2 books for the third child. But we don't know how many children are there. So if there are 2 children, it would be 2 times 2. If there are 3 children, it would be 2 times 3. If there are 4 children times 4, I can go on. And if there are, let's say, C children, and I use C because it's nice, it's children and C. It's also good to name the variables in a similar way to the names themselves. So 2 times C will be the amount that he will give away. If you give away something, you get less. That's clear. So you have 43, and he distributes 2 times C books, and he's left with 7. So that is how we go from the formulation of the problem itself to the answer. Not the answer, to an equation in one variable. So this is about equations in one variable. So from here we can solve the equation. Do you know what the answer is going to be? 18. Okay, let me see. So I will take away 43. So I get minus 2C. Then I multiply by minus half. 1 over -2, because that's the inverse. Then c is equal to 7 minus 43 divided by -2. So you told me that this value is equal to 18. I trust you, so I won't try to compute it.
No, I just subtracted 7.43 and divided by 2.
Yes, that's also a very clever way to do it. So the very nice thing about mathematics is that you can, of course, always reach the solutions in many, many, many different ways. And so this is the last easy problem we will do for today. 6x plus k is equal to 6x plus 5. Now we want to choose some number k, which will give us infinitely many solutions. And I wanted to know if anybody has an idea on how we might approach this. Yes?
Like terms, because k is a constant, so it goes with 5. And then 6x comes with the 6x, so that would be 0, which is equal to 5 minus k. And then you take the 5 to the other side, and you get k is equal to 5.
Okay, so that is one value. So you're solving for k. So here's what you did. So take the inverse of, so just take away 6x from both sides. It's the inverse of 6x, so they cancel out on both sides. You get k is equal to 5. But this equation has, in that case, does it have infinitely many solutions, and why?
It's then on both sides. So any value for x, it will give you the same answer on both sides.
Amazing. That's amazing. So this is what we have. 6x plus 5. So what we're saying here is that if you plug in any x for k, so if I set k to be equal to 5, and I just plug in 5 instead of k, then this is true for any x. And I hope you agree with me on this. And so this is really what it is. So if it's true for one x, then it's an equation. If it's true for multiple x, then it's usually something else. Here, this is what they call an identity. So if you just solve this, you get that x is equal to x, or 1 is equal to 1, 2 is equal to 2, which is just a mathematical fact. Which is, so that's just what it is. And now, as clarified within the plan itself, here you'll have some questions which we've not attempted. I think there are like 3 questions we've not attempted. So it will be your task to go on and do these afterwards. So these were the easy questions. I don't say easy from my side. I say easy from the college course perspective. If this is not easy, then it's fine. We can always talk about it. Yes. So this is the answer key. I hold it full, so that because it has everything, has the explanations and all that. But here we don't use it. So this is supposed to be medium, maybe medium rare. So this is, yeah, so as you can see, it's a bit more packed. I don't know if you see this as well, but here you notice that x is on both sides, or more precisely, it's not grouped into one term. So there are two terms which which contain x. So that is actually why it is medium, and it's not easy, because usually you need to group the like terms first, and then you can make progress with the problem itself. So here, they're trying to find the value of x minus 3. And I want to know if you have some suggestions. Maybe Alex, would you like to give it a shot? Don't worry.
I did it, but I don't know how to explain it.
Well, just step by step. Just tell us each step you did, and you can go on slowly.
Well, I multiplied the 3 with the 2x and the minus 6.
So you use the distributive property, okay? You get 3 times 2 is 6x. 3 minus 6 is 18. 3 times 6 is 18. Then it's minus 11. Okay.
Then I did the same with the 4 on the x and the minus 3.
Okay, so you get 4x minus, well, 4 times 3 is 12, I think. And then we're adding 6.
Right, I did the minus 18 minus 11, that is minus 21 and 29.
Okay.
And I did the same with the minus 12 and plus 6.
So that gives you minus 6. So you get 6x minus 29 is equal to 4x minus 6.
Then I found the 4x and the minus, the 4x to the left and the minus 29 to the right.
Okay, so you did two things. The first thing I'll write down is I'll write down the equations. So the first thing you did, you took away, you added 29 to both sides, right?
Like I just passed the minus 29 to the right side and the
Yeah, so you added 29, and so when you pass something to the other side, this is the same thing. We're saying the same thing, and then you, well, and then you passed on 4x to the other side, which is adding the additive inverse of 4x. So if you add the additive inverse of 4x, you get 0. So on the right hand side, I don't need to write 4x. I'll just write minus 6. I'll write down the 29 that I have. Here, I added 29. So it's the additive inverse. It's a 0. Don't need to write it. And then I have 6x minus 4x, which is 2x. Is that okay? So you were like 2x is equal to the minus 6 plus 29. What did that give you? 23, okay. Then x was, okay, then x minus 20, x minus 3 is 23 divided by 2 minus 2. Right? Sorry. Thank you, Flavio. Yes, but which one is the answer? You need to. Yeah, because it's.
Hello.
Yes.
I think like there is an easier and quicker way to do it, and
Yeah.
like, it gives you like without like too much calculation, it gives you like the exact answer.
Yeah, I get you. I get you. We'll do this in a moment. I'll let you do it. Okay. So you get so 3 is just 6 over 2, and so if you have 6 over 2, then you have 23 minus 6. It's 15 over 2. So that is the answer. But I think Eosius has a suggestion, and I would really like to hear it. So thank you, Alex, for your contribution. And let's see what Iosius has to say. You're still there.
For me, what I did instead of like multiplying them, what I did was like I took out 2 from the, so it is like 2x minus 6, right? So I took out 2 and it turns to like x minus 3. So
Okay.
like so it's going to be 6 into x minus 3.
So you wrote 2x minus 6 as 2 times x minus 3.
Yes.
Is this okay?
Then like you multiply 3 and 2, it gives you 6.
Yeah, and then you multiply the 2 by the 3. Okay, that's amazing. So now, yes, so now you have 6 times x minus 3 minus
Mhm.
11 is equal to 4 times x minus 3 plus 6.
Yeah. Then you can take minus 11 to the other side, which turns it to plus 11.
Yes,
And you can bring 4 into x minus 3 also to the other side. So it's going to be like 6x minus 3 minus 4x minus 3.
okay, so you have also 4 times x minus 3. You want to add the inverse, the additive inverse
Yeah.
of it. You add
Yeah.
minus 4 times x minus 3. So it's just minus of this thing. It looks
Yes.
not, but it's not scary. I hope you're not scared by it. So the minus 11, it goes away from here, so we don't write it. And the minus and the 4 goes away from here, but we still need to write it there. So we get minus 4 x minus 3, and on the right hand side we get
6 plus 11.
yeah, we get 11 plus 6. 6 plus 11. Same thing, right?
So, yeah. So it gives you 2x minus 3 equals to 17.
Okay, so 17 is equal to 2 times x minus 3. So there are two ways to think about this. The first way is these are like terms. So you have x minus 3, you have x minus 3. So you can factor the x minus 3 and you get x minus 3 times 6 minus 4. Then that gives you 2.
Yeah.
That is one way you can think about it. No, I think that's the only way you can think about it. Or you could just say these are like terms, they have the same factors, so I can group them together. So it's just 6 minus 4. 6 of that thing minus 4 of that thing is twice of that thing. So there are of course different perspectives of looking at different things. So you said this is 17, and if that is 17, then you just okay.
Divide both sides by 2.
I think yeah, I don't know how to. Yeah, I don't know how to add. I don't know how to add 23 and minus 6. I'm supposed to be a mathematics student. I don't think. Please don't tell anyone about this. Otherwise, they'll. So indeed, as Isiosus tells us, this will be. And so we already found x minus 3 is equal to 17 over 2. So it took a little bit less work and a little bit more cleverness. And then there's always the question of, well, how do I see this? How do I find out that it looks like this and I can use this very fast trick to solve the problem? And the answer to that is just you need to see it for the very first time if you've not seen it. You need to see it over and over again. And then when you get really used to it, then you say, okay, this is good. I saw this like 700,000 times before. Okay, maybe less, but and then I can do it in the same way. Darren, do you have some concerns regarding this?
I got lost somewhere.
Okay, well, let me know. So which part is it that you got lost in?
I don't exactly know. That's what I was trying to figure out.
Okay, so maybe I'll start over. I like this approach by Iosius, so I'll use it. So let's go through this step by step.
Yeah.
So 3 times 2x minus 6 minus 11 is equal to 4 times x minus 3 plus 6. So I just focus on this part. And do you agree with me that I can write 2x minus 6 as 2 times x minus 3? Okay, I'm glad we agree. And then 2 times 3 is 6. And then I have this setup where my variable is the round one. So you see, I'm solving for x minus 3. So I'm directly looking for the solution. Here, so I can do this in 2 steps if that's it's going to be too much. So I add 11. So when I add 11, I get 6 times x minus 3. And minus 11 plus 11, so it cancels out. Is that okay? Maybe I'll write it down. So I'm adding 11 to both sides. So this is what happens. Yep. And minus 11 plus 11 is 0, right? So I can just erase this. Okay. And then 6 plus 11 is 17.
Yes.
Yeah. So that's good. And now I have 6 times x minus 3, and then 4 times x minus 3. So I want to quote unquote send this to the other side, the dark side, and then I take away 4 times x minus 3 because it's the additive inverse. And so when I do this, I get the following. I get that this is equal to 17. Is this fine?
Yes.
Okay, now 6 minus 4 is 2. And so 6 times something minus 4 times something is 2 times the same thing. Finally, I divide by, or not divide, I multiply by the multiplicative inverse of 2, which is 1 over 2, to get that x minus 3 will be equal to 17 over 2. So what do you think?
Yes.
Yes, I think yes. That's amazing. I'm happy. So that's not quite bad. I think we have 10 more minutes. So let us do a couple more problems and call it a day. So this is a problem which is very suitable for the English section of the exam. But maybe we can read it together. So it talks about a tree which has a height of 6 feet. The equation tells us in how many years it took it to reach the height of 14 feet. So n is a fixed number. You plug in this number and you add, and so this is a function. You plug in n, which is the number of years, you get back the height of the planet. So it's a relation between the number of years and the growth of the planet. I think on a very intuitive level, it is clear that if you have a tree and you take care of it over the years, it will grow. And so this is made mathematically precise as follows. Okay, so what is the best interpretation of number 2 in this context? This is not it's not a direct question. And so you might face questions like this in the exam. Well, let's see. Okay, that was intentional. I'm sorry. So what I like to do when I don't understand something, I like to plug in numbers, just to understand, just for myself. On like even with very difficult mathematics, this works. So after 1 year, what happens here? So you get 2 times 1 plus 6 is equal to 14. Okay, that doesn't make sense. So that gives us 8 is equal to 14. Probably it's another n. Maybe we can try n is equal to 2. Or maybe if you already know which n works, that would be great. To know.
N is equals to 4.
Okay, 4. So yes, I mean, it is equal to 4. You can do this by plugging in 2 times 8 plus 6. Or you can solve the equation for n, and you get that after 4 years, its height becomes 14. So what's happening? What's really happening? Let's read the choices. So I think you suggested the question choice D. The average number of years it takes similar trees to grow 14 feet. I'm not even sure I understand what this means, to be honest.
Can be true.
Well, yeah, maybe we can look at other choices. I still haven't ruled it out, but maybe
But I
not.
thought the other choices are.
Yeah, maybe we'll take a look at some choices. So it says the number of years it took the tree to double its height. Well, that is not true because it was of height 6 feet. And when the height doubles, it's 12. It's not 14. So it's definitely not A. And then the average number of feet that the tree grew per year. That seems good. Let's take a look at maybe C. The height in feet of the tree when the tree was 1 year old. Yeah. Let's see. And I don't really see anything that tells us about the average number of years at least. But on a very intuitive level, if the tree grows from 6 to 14, huh?
I said after 4 years.
This is just what the problem says. So it's after 4 years because this is how many years n took the tree to reach a height of 14 feet. So this is a mathematical fact. It tells you 2 times n plus 6 is equal to 14. So after 2 times n years and then you add 6, it got to 14 feet. If that makes sense. So we find n and it tells us what n is. It tells us it's the number of years. So that's good. And we'll use that in a moment. So it goes from 6 to 14 in 4 years. Okay, that's not horrible. So how much was the growth in these 4 years? 8 feet. 8 feet, right? So 8 feet in 4 years. Okay. Then what's the average number of feet it grew per year? Yeah, because if it grows 8 feet in 4 years, then on average it's probably 2 feet in 1 year or per year. So that actually makes more sense, and I think we can go with it. Now, since we have 3 more minutes, let me take a look at this equation. So this is actually quite similar to the type of equations similar equation that we did a few moments ago. So this will be a reinforcement of the same exercise. So in this equation, A is a constant. If the equation has infinitely many solutions, what is the value of A? So we want to have we want to choose a certain value for A, which will make this equation be true for infinitely many x. Yes, Flavia?
Stay two.
You want to factor out the 2 from where?
Stay side.
From the left hand side. Okay, so you get 2 times what?
X plus x
Is equal to?
is 2x.
Okay.
Is 2.
So if I choose A is equal to 2, gives I get a statement. This is the statement that is true for any x. Yep. And so if that is the case, then if I choose A, which gives me 2, then I have infinitely many solutions to my equation. And actually, they are every single number you can think of is a solution to this equation. So it's a very big class of numbers, so to say. And I think that's good for today. We did not talk about hard problems. There are some problems here. They're very interesting. They're not too difficult. So here's how they look like. Stuff like this. But with the same foundations that we've discussed today, I think you can definitely work on them, can definitely make progress. And you are always, when I say always, highly encouraged to send me many questions as you can. So if you get stuck on 10 questions on this worksheet, you should send me a message 10 times, maybe even more if you want.
On the Padlet.
No, the Padlet is something that the previous instructor used. I won't be using it. I still have not uploaded these exercises, but I will keep you updated on Teams. And finally, I wanted to know if you have any questions before we end this. I'll ask. I'm sorry?
These are the questions that we actually count for SATs.
Yes, so this question bank is by College Board. And these questions additionally are not available in any standard practice test. So if you prepare for the SAT with your practice test, this won't overlap with it. So it's very nice in the sense. I chose the exercises specifically for this. The whole plan encompasses 19 skills, which we intend to cover all in 16 sessions. So I hope that is clear. And I don't think you'll need to worry about the other things. Today we lost a little bit of time due to some organizational stuff, but I think it is fine. We can definitely always make up for it. As for next week, we'll be discussing, let me see the topic. Not next week, it's next Wednesday. We'll be talking about 2 variable linear equations. Maybe I'll ask the question online. So I wanted to know if Josias has questions, because he's the only one who's online.
No.
Amazing. Then thank you for coming. I really appreciate that you guys are here. You're here to listen, and it's an absolute pleasure. So have a good evening, and I'll see you on Wednesday. Of course. Yeah, goodbye. And if you have questions, you can come to me now and ask.